Today we learned how to solve a systems of equations graphically. So what this means is I have more than one line on my graph, and this one is already completed for me. The first one, y equals negative x minus 2. Again, I write out my slope is negative 1 over 1. My y-intercept, the b, is equal to 2. I start at the 2 and I go down 1 to the right 1, down 1 to the right 1, and I label my graph y equals negative x minus 2. On the same set of axes, I graph y equals 2x minus 5. And again, I'm going to start at the negative 5 at the y-intercept, and I'm going to be going up 2 to the right 1, up 2 to the right 1. I do get a point of intersection, POI, point of intersection, to be 1 comma negative 3. So this means that this point will satisfy both equations, and this will hold true for both of them. So what I do want to do is I do want to perform a check. So when I perform a check in the first equation, y is negative 3, x is 1, so I do get negative 3 to be equal to negative 1 minus 2. I get negative 3 to equal negative 3, which is a true statement. I also have to check it in my next equation, y equals 2x minus 5. So I have negative 3 equals 2 times 1 minus 5, negative 3 to equal 2 minus 5, and sure enough, that does agree as well. Negative 3 is equal to negative 3. What I can now do, because we do have the use of the graphing calculator, so I want to show you how to input it into my graphing calculator. So you're going to go under y equals, if anything is here, please hit the clear screen, and I'm going to enter in negative x, make sure you use that negative button, minus 2 for my first equation, and then 2x minus 5 for the next equation. And I'm going to hit graph just to make sure that I get two graphs on my screen. And it does look like I have a point of intersection, but on the calculator screen it's very hard to see. So now what I'm going to do is on the calculator, I'm going to hit second calc. And that's going to take me to this screen, and I can scroll down to number 5, intersect. Now, the calculator asks me, what is the first curve? Make sure you are to the left of that first curve. We can use our arrows to move over. The calculator reads it from left to right. So I hit enter for the first curve, and second curve, notice where my blinking cursor is. Make sure you are to the left of that point of intersection. Guess you hit enter. And my calculator tells me my point of intersection for these two equations is 1 comma negative 3, which is what I got when I did it manually. And that is how I would like you to check it. Now let's go on to the next question that we did in class. And that was question number 7. So I have negative y minus 4 plus x to equal 0. I'm not in slope-intercept form. A couple of ways I can go about this. I could add y to both sides to make my life a little bit easier. I have negative 4 plus x to equal y. And again, I can switch the order around. Y is equal to x minus 4. It's the same exact thing. Here my slope is 1 over 1. My y-intercept is negative 4. And when I go to graph that, I start at the negative 4, and I'm going up 1 to the right 1. Up 1 to the right 1. I'm going to draw a nice straight line with arrows, and I'm going to write my original equation on that line. Okay, let's take a look at the next one. I have negative y equals negative x minus 3. That's equivalent to negative 1y, so I'm going to divide every term by negative 1. Y always has to be positive. So I get y to equal x plus 3. My slope here is 1 over 1. My y-intercept is 3. So I'm going to start at the positive 3. And my slope is telling me I'm going to be going up 1 over 1, up 1 over 1. And this is what my line is going to look like. And again, I'm going to label it with the original equation. Now, what is my point of intersection? Here I don't have one. These two lines will never intersect. They are parallel lines. How do I know they are parallel lines? Parallel lines have equal slopes. They are always going to be the same distance apart. In this case, my slope is 1 over 1. In this case, my slope is 1 over 1. They have equal slopes and different y-intercepts, so they will never intersect. They will never intersect. They have equal slopes. So therefore, what is my solution to this system? I don't have one. My answer here is going to be no solution. I do not have a point of intersection. Therefore, I do not have a solution that will satisfy both equations. When I take a look at the next example, number 8, I have 6 plus 3y equals negative x. Again, let me get myself into slope-intercept form. So I'm going to isolate my y and make sure I divide every term by 3, and I get y to equal negative 1/3 x minus 2. My slope here is negative 1/3. My y-intercept is 2. I'm starting at the 2, and I'm going to be going down 1 to the right 3, down 1 to the right 3. And make sure, please, you do it in the opposite direction as well. Draw yourself a nice straight line, and let's label with that original equation. 6 plus 3y equals negative x. Make sure my x and y axes are labeled. Now let's take a look at my next line. I'm going to do this in blue. 0 equals negative 12 minus 2x minus 6y. I need to get myself into slope-intercept form. I'm allowed to add 6y to both sides. So now I have 6y equals negative 12 minus 2x. Again, if you want to put it into slope-intercept form, 6y equals negative 2x minus 12 is fine. Divide every single term by 6. So I'm going to get y to equal negative 1/3 x. I simplified the negative 2 over 6 minus 2. I am going to start to graph this. So when I go to graph this, I start at the negative 2, and I'm going down 1 to the right 3, down 1 to the right 3. And I should realize here, woohoo, I have the same exact line. Same line. I have the same exact formula for both of those lines. If I have the same line, I am going to have infinite solutions, because every single point that lies on that same line could be a solution to both of these equations. So that is my other scenario that I have, infinite solutions. Now let's quickly take a look at question number 12, which is in our homework, because I do want to graph this with you as well. Y is equal to x. My slope here is 1 over 1. My y-intercept is 0. And again, I'm going through this rather quickly. This should be a review for us. We are in slope-intercept form already. And y equals 1x plus 0. So when I go to graph this line, this is the line I get, y equals x. When I take a look at my next line, y equals negative x plus 4, my slope here is negative 1 over 1. My y-intercept is 4. I'm going to start at the 4, and I'm going down 1 to the right 1, down 1 to the right 1. And I'm going to graph this fine line in both directions. And I'm going to label y equals negative x plus 4. It does look like I have a point of intersection here. I'm going to circle it and label it POI. And I have to show on my paper my POI is going to be at 2, 2. So let us check. Y equals x. 2 equals 2 is a true statement. Y equals negative x plus 4. 2 equals negative 2 plus 4. 2 equals 2. That checks as well. So therefore, it looks like I am okay. Let us now use our graphing calculators, and let us make sure we are fine. Go under y equals and hit the clear button. Clear out what I have in there. Let's type in my first one. Y is equal to x. The second one, y is equal to, make sure you use the negative button, negative x plus 4. Let us graph those. And sure enough, I get the graph that looks like I have on my paper. How can I see if I have a point of intersection? Second, calc. Go down to number 5, intersect. My first curve, again, make sure you use your arrows, make sure you are to the left of that point of intersection. Second curve, I am to the left of that point of intersection. Guess you hit enter, and sure enough, my calculator takes me again to point 2, 2. So I have checked it, and I am good.